Okay, the first question of this June 2018 paper 3-2. It says showing all necessary working, solve this equation, giving your answer correct to three significant figures. So I would first of all say, okay, let this 2 raised to power x is equal to y. So my question is going to be 3 absolute y minus 1, that is going to be equal to y. So this absolute y minus 1, that is equal to y over 3. When I remove this absolute mark over here, so this would be y minus 1 equal to y over 3, or y minus 1 is equal to minus y over 3. That is what we do when we have the absolute equations, the modulus functions here. So we have 3y minus 3, that is equal to y. We have 2y equal to 3, and your y is going to be 1.5. From here you have 3y minus 3 equal to minus y. You have 4y equal to 3, and your y is equal to 3 by 4. Okay, so we need to go back here, and since we have to find the values of x, so from this you have 2 raised to power x equal to 1.5, or you have 2 raised to power x that is equal to 3 by 4. So you apply the log to both the sides. This is x ln 2. Don't use the calculator, okay? This is 1.5. Why I am writing it as 1.15? You see, this happens when you are towards the end of the day. Okay, so this is ln 1.5, and now you have to use the calculator here. Okay, and here this is x ln 2, that is ln 3 by 4, and this is x is going to be ln 3 by 4. Acha. So please give me the values. Answers. What is this first answer here? ln 1.5 over ln 2. 3? 0.585. Remember, he has told us to write the answer correct to three significant figures here, okay? And what is this one? 415. So these are the two solutions. Let's check the answer quickly. I have the marking scheme with me. So minus 415, and where is the other one? Okay, this is 0.585. Okay, so 0.585. Yeah, so both the answers are correct. Okay, well, let's move on to the second question, guys. This is the second question here. Okay. Okay, it says showing all necessary working, solve the equation this equal to 2. So this is going to test your ability, your skills on the double angle formulas here. So let's write that formula. We don't have a formula for the cotangent, but we have a formula for the tan. Okay, so tan alpha plus beta. This is, by the way, there in the formula booklet as well. Okay, tan alpha plus tan beta over 1 minus tan alpha tan beta. Okay, so we have to solve this equation here. So I will be changing this into 1 over tan theta plus, I'll be writing the reciprocal, okay? 1 minus tan theta and tan 45, okay? Over tan theta plus tan 45, and that is equal to 2. I should quickly change this tan theta into y or whatever so that this looks like less horrible over here, okay? Let me keep this as y over here. This is 1 over y plus 1 minus y over y plus 1, that is equal to 2, because we know that tan 45 is 1. Okay, tan 45 is 1, and your tan theta is y. Okay, so now this is a simple grade 6 question here. So we have this 2y square equal to 1. So your y square is half. Your y is plus minus 1 over under root 2. Don't use your calculators at this level, okay? So, so there's a mistake here. This has to be 3y square. This is 1 over 3. This is, oh, this is going to be those one of those typical values, Hannah. 1 over under root 3. Okay. So corrections. See, this happens when you lose your focus. Okay. This is 1 over 3. This is 1 over 3. So I think that is going to be sine 30, Hannah. So tan 30 is this. Okay. So I'm replacing your y with the tan theta. So tan theta is going to be plus minus 1 over under root 3. Remember, we have to be within this limit here. So since we have plus minus, so tan is going to be positive in both of these quadrants here. You must notice one thing that I haven't calculated, I haven't used calculator anywhere throughout. So try to keep the things as long as you can keep them as exact, okay? So was it 30 degrees? Hmm? I think that is 30 degrees. Yes. So this theta is going to be 30 and 150 degrees. Tan inverse of 1 over root 3 is 30 degrees. Anna? Yes. So what do we have here? Where is the answer? Okay, so that's the right answer here. Okay. So now let's move on. Third question. Okay. Here is the third question, guys. Third question. So it says this point is x comma y. You should not hesitate in writing this Pn as y. Okay, this length of this Pn is y, and it says the point n is the foot of the perpendicular. Okay, the curve is such that for all values of x, the gradient of the curve is positive. Okay, and Tn is 2. So guys, the gradient of the curve is basically dy by dx. And you see this is a tangent over here. So the tangent of this, I mean the gradient of this line PT is also y over 2. And you see the gradient of PT, that is y over 2. And this gradient of PT and dy by dx are the same thing. So you can write it as y over 2. So you know this is justified that your dy by dx is going to be half y. Okay, then we see that it says the point with coordinates 4 comma 3 lies on the curve. Okay, so there is a point 4 comma 3. Let me note it down. Oh, it's here. Solve the differential equation to obtain the equation of the curve of the expression y in terms of x, y in terms of x. Okay, so we have this equation dy by dx that is going to be y by 2. So this is to start with, that is y by 2. So you know you have to split this equation in such a way that one side should have the dy, the other side should have the dx. Okay, so this is dy. I'll bring this y here as well. And this is half dx. Got it, bacho? How can this can be such a simple equation here? So this is going to be ln y, that is equal to half x plus c. And let's put this point into it. So this is ln 3, that is equal to 2 plus c. So your c is ln 3 minus 2. Okay. So let's quickly write down the equation. This is ln y is equal to half x plus ln 3 minus 2. So we need y in terms of x. So where I can, okay, there is no need to simplify this. This is going to be y is equal to e raised to power all of this half x plus ln 3 minus 2. Okay, and it says I can leave it up to this, or if you want to, you have extra time, you can write it as e raised to power half x times e raised to power ln 3 times e raised to power minus 2. I know that this e raised to ln 3 is 3. Hmm? E raised to power ln 3, that is equal to 3. So maybe we can write it as 3 e raised to power half x minus 2. Let's see what is the answer. Okay, this is the, yeah, he has written it the same way we have written it down. 3e half x, it's the same answer we have. You could, you could leave it up to this as well. There is no harm because you have y in terms of x. Okay, so that is it. And then so much area is given for this question. Okay, uh, question number 4 here. Show that all of this is this. Okay, so this is an identity. Keep an eye on this sine x over 1 plus cos x. You have to show this left hand side to be equal to this. So what is the first clue for me, guys? How can I start solving this? What is the first hint, first clue? Yeah, you see, you have the 2x over here, and there is no 2x on the right hand side. So that is a hint for you, okay? So let's, on the side notes here, I should say that, okay, my sine 2x is sine 2x is 2 sine x cos x, and 1 minus cos 2x. Guys, 1 minus cos 2x is 2 sine square x. Okay, so let's put them in here. So it's 2 sine x minus 2 sine x cos x over 2 sine square x. Okay, so you have 2 sine square x.
सर ये पहले 2 sin x को सॉरी इधर में न्यूमरेटर जैसे तो फैक्टराइज कर सकते हैं ना 2 sin x कर 1
1 minus
cos
cos
x
x.
cos x को न्यूमरेटर से इसी तरह निकालना
Yeah, let's do that. No problem with that. This is 2 into the sine square x is basically 1 minus cos square x. Okay, and you can write it as 1 plus cos x into 1 minus cos x. So 2's are cancelled, these are cancelled. So you have sine x over 1 plus cos x, and that is equal to the right hand side. Okay, so we move on to the second part then. Okay, it says hence. Now when you have hence, it means we have to use all that working done in the first part. Hence, showing all your working, we have to integrate this 2 sine x minus 2 cos x. Oh, sorry, and like we have to integrate this. So uh, let me clear this area from here. Okay, so before I erase this, I am just keeping this intentionally here. So I will be writing it as limit from pi by 3 to pi by 2. Instead of all of this, I'll be writing it as sine x over 1 plus cos x. Oh, now this is one line integration here. Who will tell me what is its integral?
सर एक सेकंड क्या कहते हैं cos x को करते हैं तो
Yeah, you're there, Maria. Yes. You see, whenever you have a rational function, you have to see that, all of this has a power 1. If you move this to the numerator, its power would be minus 1. Okay. So then you pray to God, Ki Ya Allah, Kash, if I have its derivative up here. So you do have that. What is derivative of 1 plus cos x? Minus sine x. Okay. Yeah. So you need to have a minus here and a minus here. Okay. So now this simply becomes minus limit from pi by 3 to pi by 2. This is ln 1 plus cos x. That's it. This was just one line integration. So this is minus, let's put the limits here. This is ln 1 plus cos pi by 2. That is 0, है ना? And then minus ln 1 plus cos pi by 3. Cos pi by 3 is half, I think. Yes. So this is minus uh, ln 1 and minus ln 3 by 2. So this is going to be ln 3 by 2. That is your answer. Let's check quickly the answer here. This was the fourth question. Hmm? Yeah, this is ln 3 by 2. Okay, so that's great going. And let's move on to question number 5. Okay, let me clear this. Okay. Okay, if you really want to have a good grade, so you must be going one step ahead, okay? So this is the differentiation of implicit functions, okay? So I have to show that the dy by dx is this over here. Let me draw a line here so that I can double my space. This is really a good tip. While, attempting your paper, you should draw a vertical line on your paper so that you can double your working space over here, okay? So now I would like to expand this. This is x cubed plus 3x square y minus y cube, that is equal to 3. Okay, so the derivative of x cube is 3x squared. Remember, there is a product. So remember that product, okay? So you will be applying, Harira, u dot v here. So the derivative of x square is 2x and y would remain as it is. I'm using these different colors here, okay? Then plus, now this x square will remain as it is and the derivative of this y would be dy by dx. Okay, this is it. And then you have minus y cube, so that will be minus 3y square dy by dx, and that is equal to 0. Now here is the part where majority of you make a mistake. People just write this 3 as it is. The derivative of 3 has to be equal to 0. Okay, so now let's simplify this a bit. This is, you see, 3 is common throughout. If you can see that, so you can get rid of this 3. So I'll be writing this as x square plus 2xy plus x square dy by dx minus y square dy by dx, that is equal to 0. Keep an eye on this as well, okay? So you have dy by dx common from here, and we have x square minus y square, and this expression on the whole, it needs to go to the other side. So this is minus x square plus 2xy. So finally we have this dy by dx, that is minus of this x square plus 2xy over this x square minus y square. You have y square minus x square over here. So you multiply this minus inside here. So you have that required form. So that is your x square plus 2xy over y square minus x square. Okay? So we got the required result here. Let's see, what do we have in the second part? Hence, find the exact coordinates of the 2 points of the curve at which the gradient of the normal is 1. Okay, the gradient of the normal is 1. Okay, so if the gradient of the normal is 1, what will be the gradient of the tangent? Minus 1, because the tangent and the normal, they are perpendicular to each other, so their gradients would be the negative reciprocals of each other. Okay, so I will be writing this thing: x square plus 2xy over y square minus x square, that is equal to minus 1. And I have the equation here. This equation was x square into x plus 3y. 3y tha kya tha ye? And then you have minus y cube, that was equal to 3. So let me cover all this area because I have to show all this working here. Okay. Okay. So let me maintain this line here. So guys, you will be getting an equation from here. This is x square plus 2xy, that is minus y square plus x square. You have two equations in x and y, and you have to solve them simultaneously. Okay, so this is going to be, yeah, x square is cancelled out with this x square. Okay, can I say that my, okay, this 2xy plus y square is equal to 0, and no, I think I should let it be the way it is. Okay, and I'll take out y from here. Okay, so this gives me x is equal to minus y square over 2y, है ना? And that is minus y over 2. That is your x. अच्छा बच्चों, this is exactly the same way. If you recall your P1, when you guys put your dy by dx equal to 0, so there you people used to get x directly, one or two values of x, and you used to put that x back into the original equation, and that gave you the corresponding y coordinates. But here the situation is different. When you put your dy by dx equal to the given gradient or equal to 0, you get a relation in x and y. You don't get that x or y directly, okay? So you have to put this x or y back into the original equation. So that is what I'm going to do over here. So this is going to be y square over 4, that is minus y over 2 plus 3y minus y cube, and that is equal to 3. Let's solve that quickly. This is minus y cube over 8. You have to be very patient here while solving this equation. Okay, 3y cube over 4 minus y cube, that is equal to 3. I'll be multiplying the whole equation by 8. So I have minus y cube plus 6y cube minus 8y cube, that is equal to 24. Okay, so this is going to be uh, this is going to be minus 9, and this is 3y cube, that is equal to 24. Achha, by the way, it says the 2 points. Okay, this is going to give you 1 point. So I think we have made a mistake here. I need to correct that. I was about to do that, like, and I just missed. I got distracted and I made a blunderous mistake here. Guys, look at this. We should not be canceling out the variables ever. So this was basically, you remember I wrote it like this, Anna? And then I went back to that. So I should take y common from here. This is 2x plus y. So one of y coordinate is, I was going to lose this y coordinate by doing this. So y equal to 0, and the other one is y is equal to uh, y is equal to y is equal to minus 2x, है ना? Oh, so this is going to change all of this. So a timely like, awakening over here. Okay. So I would be covering all of this. This is 2y plus, this is perfectly right now. Did I make any mistake again here? No. Okay. No, 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 no. Oh, I was about to erase all of this. This is all right because this will give you eventually your x as minus y over 2. Okay. So now this is y equal to 0. If so, let's put that y into this equation over here. So this will give you um, x square into x plus 0 minus 0 equal to 3, and your x cube is equal to 3, and your x is the cube root of 3. So one of the points is going to be cube root of 3 comma 0. Let's find the second point. So this gives you y equal to y cube equal to 8, and your y is equal to, yes beta, minus, यहाँ पे oh yes beta, thank you again. This is going to be minus 2. Okay, so now we put this x into this equation. So y into this equation, this is minus into minus 2 over 2. So that is going to be 1. So the other point is going to be 1 comma minus 2. Let's check the answer. This was question number 5 part 2. Yeah, one is here. You can see this is one of the answers, cube root of 3 comma 0. That is what we're going to miss. And the other answer is here, 1 comma minus 2. So alhamdulillah, this is perfectly all right. Okay, so this is your answer here for this question.